Hi students, I'm Praveen Sebastian Paul. In this lecture, we are discussing the characteristic of a diode. This figure shows the static voltage current characteristic for a low power PN junction diode. We can see two types of characteristic, the forward biasing characteristic as well as the reverse biasing characteristic. And we are discussing each of them. Firstly, we are going to discuss the forward characteristic of a diode. When a diode is forward biased and the applied voltage is increased from 0, hardly any current flows through the diode in the beginning. It is so because the external voltage is being opposed by the internal barrier voltage VB, whose value is 0.7 volt for silicon and 0.3 volt for germanium. As soon as the VB is neutralized, current through the diode increases rapidly with increasing applied battery voltage. It is found that a small voltage of 1 volt produces a forward current of about 50 milliamperes. The diode will burn and fail to function if the forward voltage is increased beyond a certain safe limit. The forward voltage at which the current IB start to flow is known as knee voltage or cut-in voltage or cut-off voltage or offset voltage. So this is the forward characteristic of a diode. So as we mentioned, for a silicon based diodes up to 0.7 volt the current doesn't flow. After that, if we are applying a voltage, the current will flow through the diode, and it should be noted that those current should not exceed the safe limit of that particular diode. Similarly, in the reverse bias condition, when the diode is reverse biased, majority carriers are blocked and only a small current due to the minority charge carriers flow through the diode. As the reverse voltage increases from 0, the reverse current very quickly reaches its maximum or saturation value, that is represented in IO, which is also known as a leakage current or reverse saturation current. It is of the order of nanoamperes for silicon and microamperes for germanium. As seen in this figure, when reverse voltage exceeds a certain value called breakdown voltage, which is represented as VBR, the leakage current suddenly and sharply increases. The curve indicates zero resistance at this point. So this is represented in this figure with breakdown voltage and the current characteristics. So dear students, now we are discussing the temperature dependency of a PN junction diode. The barrier voltage of a PN junction depends upon three factors, namely density, electronic charge and temperature. For a given PN junction, the first two factors, that is density and electronic charge, are constant, thus making the value of the barrier voltage VB dependent only on temperature. It has been observed that for both germanium and silicon, the value of VB decreases by 2 millivolt per degree Celsius. Mathematically, the decrease in barrier voltage is delta VB is equal to minus 0.002 into delta T, where delta T is the increase in temperature in degrees Celsius. As shown in this figure, in reverse bias region, the breakdown voltage VBR is increasing with the increase in temperature, and the reverse saturation current IO is increasing to almost double in magnitude for every 10 degrees Celsius increase in temperature. So this is the temperature characteristic of a diode. So as we mentioned, if the temperature increases, the increase of breakdown voltage also will occur. So dear students, these are the basic characteristics of a diode relating with forward characteristic, reverse characteristic and temperature dependent characteristic. So dear students, hope you had understood. So dear students, kindly write down this assignment question. Our question is, write notes on the characteristics of a PN junction diode. So dear students, in the upcoming lecture we will discuss a half wave rectifier using a diode. So dear students, see you soon. Until then, goodbye, thank you and all the best.